For number 4, I have the sum as n goes from 1 to infinity of -1 to the n over n cubed plus 1. And what I'm thinking as a teacher and as somebody who's had a lot of practice with these problems, I'm thinking, well, I'm thinking alternating series test. I'm also thinking P-series. P-series. And the comparison test. All those things. What do you expect this one's going to do? This is going to converge. This is going to converge absolutely. P-series, what is P? P is 3. So the sum of 1 over n to the 3rd power is going to converge. If I just take off that -1, it's going to converge absolutely. I'm going to pretend I don't know that. And I'm going to try to use our good friend, the ratio test. So, solution, we'll try the ratio test. Just for fun. Because that's something you might think of. And the ratio test, I'm looking at this problem, and this is the a sub n. So I need to form this ratio, the fraction a sub n plus 1 over a sub n. So this is going to be the absolute value of -1 to the n plus 1 over n plus 1 to the 3rd power plus 1 times n cubed plus 1 over -1 to the n. And that ratio then would be the absolute value of -1 to the n plus 1 over -1 to the n times n cubed plus 1 over n plus 1 cubed plus 1. And I'm pretending we multiplied n plus 1 to the 3rd power completely out. N plus 1 times n plus 1 times n plus 1. And what's the leading term? It would be 1n cubed. Here, let's do the limit. The limit as n approaches infinity of the absolute value of -1 to the n plus 1 over -1 to the n times n cubed plus 1. Let's see, I think I will multiply it out. N cubed plus 3n squared plus 3n plus 1 plus 1. That's what you would get if you multiply it out. And I'm looking now, the leading terms, the top and the bottom right, they're n cubed. That limit as n approaches infinity is going to be 1. This is going to be 1. This limit is 1. What does the ratio test tell us? Nothing. Nothing. We can't determine it from the ratio test. So we cannot determine anything from the ratio test. We have to use something else. Now, the ways to determine absolute convergence or conditional convergence, there's 3 ways. We could use the ratio test, we could use the root test, or we could use the definition of absolute convergence. If the ratio test didn't work, the root test will not work. So I need to write this so that you make sure you have this. So note, there are 3 ways, well, let's put the R there, 3 ways to determine absolute convergence. we could try the definition of absolute convergence. We could try the ratio test, which we just tried. We could try the root test. If the ratio test or the root test doesn't work, you get the limit is 1. Don't try the other one because you're going to get the same result. So we tried this one, no result. So I know the root test is going to be no result. So we got to go with the definition of absolute convergence. So I did all that just to show you sometimes you might try the ratio test and you come up empty. Well, let's try the definition of absolute convergence. Here's the problem again. The sum as n goes from 1 to infinity of -1 to the n over n cubed plus 1. Well, the definition of absolute convergence is just to say, well, let's try this. Does the sum as n goes from 1 to infinity of the absolute value of -1 over n cubed plus 1, does this converge? That's the definition of absolute convergence. What is this? So the sum as n goes from 1 to infinity of 1 over n cubed plus 1, that's the question. And there I'm thinking P-series, I'm thinking comparison test with P-series. And does this converge? Yes. So does it converge? Yes. This is, here I'll just write use comparison test. Think about which comparison test. Use a comparison test with the series as n goes from 1 to infinity of 1 over n cubed, which is a P-series. P equals 3, which is greater than 1. So this converges. Do you have that inequality we need for the comparison test? Yes. So, all right, and 1 over n cubed plus 1 is less than or equal to 1 over n cubed for all n, and n started at 1. So the one we're looking at, this does converge. So the sum as n goes from 1 to infinity of 1 over n cubed plus 1 converges. And that means our series we were looking at, the sum as n goes from 1 to infinity of -1 to the n over n cubed plus 1 converges absolutely.